If you look at those famous humanoid robots, from Boston Dynamics to Figure Robotics, marvels of engineering, but they cost hundreds of thousands of dollars to build. Now, let's take a look at their China's rivals. The Unitree newly launched R1. Its retail price is just $4,300, while Noetix Boomi is priced at even more aggressive $1,600. How is this physically and economically possible? Are these robots companies stealing tech? Actually, the biggest breakthrough in China's robotics may have had almost nothing to do with the robotics itself. It came from the electrical vehicle industry. In this video, I'm going to decode how the bloodiest EV war in human history accidentally collapsed the cost of robotics' eyes, brain, and the muscles. By the end of this video, you'll understand why this is not really a story about robots. Remember those massive spinning buckets on top of early self-driving cars? That is a mechanical LiDAR, the 3D eye of a machine. 5 years ago, companies like Waymo outsourced these high-tech devices for $75,000 a piece. When they started to manufacture them in-house, it still cost roughly $7,500. Today, a modern solid-state LiDAR is compact enough to fit in the palm of your hand. More importantly, the cost has dropped significantly to just a few $100s. What exactly drove this 90% reduction? It wasn't a single laboratory breakthrough. The answer lies in the intense competition within China's electric vehicle market. It is a direct result of extreme scale. By 2025, China's annual production of new energy vehicles reached roughly 13 million units, accounting for 62% of the global market. Here's the economic trick. When an intelligent car requires a rooftop LiDAR as standard equipment, a highly sensitive laboratory instrument suddenly must be manufactured at the speed of a printing press. When you spend billions in R&D across tens of millions of vehicles, the per-unit cost is reduced to a fraction of its original price. It's similar to a Hollywood blockbuster. The production may cost $300 million, but because it's shared by a global audience, your individual ticket only costs $15. China's LiDAR giants like Hesai didn't initially care about robots. They were desperately building automated mega factories just to feed the massive supply chain appetites of EV giants like Xiaomi, NIO, and Li Auto. As automotive-grade production lines reach the peak of extreme scale, this cost-effective hardware inevitably migrates to adjacent industries. Look at Delivery Rover, a warehouse AGV, or even $1,600 Unitree robot dog. They all share one secret. They are all pulling from the same parts bin. These cutting-edge optical sensors are actually repurposed hardware from the EV industry. Actually, nobody planned this. In January 2026, Hesai announced to double its annual LiDAR production capacity to over 4 million units. But there's a catch. Seeing the physical world is completely useless if the machine lacks the computational horsepower to understand it. This brings us directly to the brain. Now that the robot has affordable vision, it faces a massive bottleneck: the brain. Processing millions of 3D data points per second used to require an expensive cloud server. Not anymore. Look at a standard $40,000 family EV in China, like the NIO ET7. Tucked inside its chassis are 4 NVIDIA Orin chips, delivering over 1,000 TOPS of computing power. What does 1,000 TOPS actually mean? TOPS stands for trillions of operations per second. It means this daily driver has the same raw processing power as 10 of the world's most powerful gaming PCs combined. Yesterday, this huge compute was bolted into a heavy car chassis. Today, because of mass production, it is literally being unplugged and dropped straight into the chest cavity of a humanoid robot. Elon Musk once described Tesla as just a robot on 4 wheels. He was proving accurate. But in China, you don't have one Tesla. You have a ruthless wolf pack of dozens of EV manufacturers racing to survive. None of these companies were burning cash to teach robots how to work. They simply want to stop their cars from smashing into highway guardrails. But avoiding guardrails accidentally solves the hardest problem in robotics: spatial awareness. But there's another fact you definitely cannot ignore today. Modern AI isn't built by programmers manually typing code. It is organically trained by oceans of data. Right now, tens of millions of sensor-loaded EVs act as an unstoppable fleet of mobile data harvesters, absorbing billions of miles of unpredictable edge cases and spatial geometry. The robotics industry in China didn't spend a single dollar gathering this. They simply freeloaded off the billions of dollars in tuition fees already paid by the auto sector. But many of the foundational technologies overlap far more than most people realize. And that brings us to the hardest part of manufacturing robots. Software code can be effortlessly updated from a street coffee shop. But gravity and physics do not accept software updates. In the unforgiving physical world, forcing 100-pound steel chassis to lift heavy loads and work smoothly is literally a manufacturing nightmare. For decades, robotic motion relied on actuators packed with components like planetary roller screws. What exactly are those? Imagine the intricate mechanical muscles required to deploy a commercial airplane's landing gear. Historically, this belonged strictly to aerospace. They were custom-made, low-volume, and absurdly expensive. Enter massive automotive suppliers like Zhanhua. These multi-billion-dollar giants spent years perfecting steering columns and thermal management systems. They never planned to build robots, but when they finally analyzed humanoid, they discovered a glaring industrial blind spot. Wait, isn't a robotic joint basically just a miniaturized car steering column? The pivot was brutal and immediate. They took their massive 10,000-ton die-casting machines, the exact same relentless assembly lines used for electric vehicles, and repurposed them to stamp out robotic limbs. By applying that terrifying automotive scale, the production cost of critical mechanical joints is projected to crash by over 70%. Giants like CATL and BYD currently control roughly 70% of the world's EV batteries. Their tech was built for one brutal task: pushing a heavy 2-ton SUV through highway winds for 500 miles. But when you take that same car-grade power and put it into a lightweight robot, it becomes a game changer. Suddenly, you have a machine that can pull double shift of heavy labor. We're not witnessing a carefully masterminded government-planned robotic uprising. We're simply looking at an accidental, incredibly affordable industrial byproduct left behind by the most ruthless electric vehicle war in human history. So, we have connected the dots. The affordable visual sensors, the fully trained AI brains, and heavy-duty mechanical muscles. They are all just the spoils of brutal automotive war. But looking at this data leaves us with an unsettling question. If an accidental EV war managed to create the world's most cheapest robots, what exactly happens when China starts building them on purpose? To find out how far this robotic price tag can actually fall, I started pulling out supply chain data and financial reports. And every single data point led me directly to China's ultimate EV titans, BYD. In the next video, I'm going to decode the ruthless mathematical paradigm BYD used to conquer the car market, so you can instantly see the exact, unavoidable blueprint for the future of global robotics. In the meantime, click this video to check out some of the shocking details I dug up from Unitree's IPO filing. I'm Justin. If you're into deep side of tech, subscribe now. And I will see you next week.